Hi, I'm Matt Needham, and this is my lecture on installation of specific appliances based on the Uniform Mechanical Code. The Uniform Mechanical Code, this chapter, installation of specific appliances, is mainly about residential and commercial equipment and doesn't apply to industrial equipment as stated in the beginning of the chapter. And this would be industrial equipment, bigger things over 600 volts and for industrial applications. Okay, here it starts off about the type of gases, and that if an appliance is designed for one type of gas, you can't just decide to modify it or use a different kind of gas. Like for instance here on this furnace, on this upflow type furnace, there's these orifices or spuds that come off the manifold on the gas valve, and these openings are sized for, let's say, natural gas. Now sometimes there are certain furnaces and things that are made maybe for more remote country living kind of thing where you can use propane, but then you have to get a little kit where you screw in the different size spuds and make some adjustments so that you can use it for that. But you can't just arbitrarily drill holes or change the sizes or just flip one gas to another. Okay. Now we have solid burning, fuel burning appliances. We have to make sure that we have adequate combustion air and the proper anchorage of chimneys, and things should be away from combustibles. Again, solid fuel burning appliances might mean like using hardwood or wood to burn, or maybe coal or something like that, which we don't have much of on the West Coast. Sometimes wood-fired ovens are popular here, and recently in California, I believe the restrictions have gotten more and more extreme on wood-fired ovens and things of this nature. Okay. Let's move along. Switches in electrical supply lines. It talks about you have to have a disconnect or a way of shutting off the power, and it has to be within sight of the equipment and within 50 feet. So you can't just say, well, I'm working on, and I've worked on rooftops bigger than the size of football fields, really, and you can't say, well, 100 feet over there, it's by a straight shot, I can see it. You have to have a means of disconnect there near the unit, okay? And then we have installation in garages for heating systems. Equipment has to be at least 18 inches off the ground, like in a garage, okay? And that's because people store flammable things in a garage, gallons of gas, they work, there's sawdust, there's different paints, and things like that. And if somebody were to knock over a gallon of gas or whatever, and it were to go right into a heating appliance, and that flame was on the burner or a standing pilot or something like that, then you could have a big disaster. So they have to be up off the floor at least 18 inches. Now the one exception for that, which may sound a little unusual, would be dryers. They don't require that for dryers, and the logic behind it is that it's not the kind of thing that starts automatically in the middle of the night. No dryer is just going to say, all right, you put wet clothes in here 3 hours ago, I'm going to start at 2 a.m. We don't have that. They're manually started. So the thought is that because of that, it's not required. The code is pretty more like, treats it like a portable piece of equipment: washers, dryers, ranges, stoves, this kind of thing. Okay. All right, we have different types of forced air furnaces. Here we have an upflow furnace where the air comes in the bottom, and this right here, this is the air filter, and this is actually the official symbol for air filter on blueprints from ASHRAE. Okay, so I have that, and then we have the air going sucked in the bottom, and then the fan pulls through, filters the air, and then blows it up over a heat exchanger. The heat exchanger is metal that gets heated from the fire, and I've drawn this in blue. And we have the gas valve here that shoots the flame out and heats up, let's say, the inside part of the metal. And then the metal, a lot of times, I don't know, they don't clarify this in any books. The metal of the heat exchanger, the outside of the metal, is what heats the air that you come in contact with. And that we have no direct connection between the fire and the air that you come in contact with centralized furnaces for homes or businesses. And so then the heat exchanger adds heat to the air, and then it blows up over into the plenum, and you can get warm air. And then the products of combustion from the heat exchanger goes up the vent or the chimney pipe, so that when you are burning it, you are getting, not really, you shouldn't be getting smoke. You have a problem if you have that, but products of combustion are flowing through the heat exchanger, and then it goes up this vent or chimney pipe out the roof. And then the air that you come in contact with has nothing to do with that. And a lot of times people say, oh, you have a cracked heat exchanger, you need a new furnace. Well, maybe. It's kind of hard, by the way, in my belief, especially like on the West Coast, to get carbon monoxide poisoning from a furnace. First of all, you'd have to have a terribly cracked heat exchanger. Second of all, you'd have to have orange in your flame and be producing a lot of carbon monoxide, because a perfect flame, a complete combustion, has no carbon monoxide in it. Not that we get perfect combustion, but we get very close. If you want to take a carbon monoxide meter and put it up for your supply air vent, I defy you to read more than 4 or 5 parts per million, even if you had a slightly cracked heat exchanger. And then you'd have to run the furnace for 6 or 8 hours straight, which is not that cold in the West Coast to do that, to get it warm enough. So all those things would have to go wrong to get carbon monoxide poisoning from a central furnace, probably using natural gas with a heat exchanger. Things can go wrong. There's other scenarios where you can get carbon monoxide poisoning more easily than from this, but that's a pet peeve of mine. Now, that's upflow furnace, and then sometimes y'all furnaces where we take the return air from the top and we blow it out the bottom. We have floor registers. That's typically when you only have heating and not cooling. You tend to have that. And then a real popular one is horizontal type, where all of what you see is in an attic, and it horizontally is there, and so that you don't see it or come in contact with it. It doesn't take up closet space like these other furnaces, and then it blows the air across and down. Okay. Let's move on. Again, you should always be following the manufacturer's instructions. That's like such a big thing of the code. Again, all the equipment is generally approved by the UL, Underwriter Laboratories. And the manufacturer says sometimes, here's the instructions to deal with it safely being put in, and that gets approved. And then the building inspector's job, again, is how does that piece of equipment integrate with the building? How is it mounted? What are the clearances from flammable things? This kind of thing for safety. So it's very reliant on the manufacturer's instructions, and those instructions should be approved along with the equipment, and then those instructions should be there with the equipment when it's installed. Okay. All right. A central boiler or furnace shall be installed in accordance, again, with the manufacturer's instructions, really all equipment. Okay, let's move on. Okay, temperature pressure limiting devices. We have temperature pressure limiting devices where if you get over temperature, over pressure, we're going to relieve the pressure. So really we're talking here more about like limit switches, where it's going to shut down with excess pressure for a boiler or temperature for a furnace, which would be like 250 degrees right here. We're going to have that. And then we're also, for boilers, going to have a low water cutoff, where usually a boiler is partially filled with water. And then if you're making steam, then the top portion of the boiler is steam, and we have a float switch that is going to shut the boiler off if you get low on water for safety. Okay. Also, for pressure relief valves, this is where I've hesitated. It's you have overpressure. If something were to happen and everything went wrong and a gas valve stayed stuck open while the flame was on, the only way to stop that would be to manually shut the gas supply off. Okay, so if all that goes wrong for your hot water heater at home, we have a pressure temperature relief valve that's going to discharge that. And then it does say in another part of the code here that it can't like be right against the floor. You have to be up off the floor. I think it's 18 inches. That's so that if it overpressurizes and hits the hot water and steam, it won't hit so hard that it flashes up into your face. It may burn your ankles, but it's not going to flash up and blind you or something like that. Okay, that's why you'll see on hot water heaters and boilers and things like, hey, there's this pipe that's open that just stubs off and stops right here. Where's that going to? What does it do? It's there to relieve pressure in case of a emergency. And again, it doesn't want to discharge at your face and doesn't want to discharge this far above the floor so it won't bounce and hit up. It wants to just scald your ankles. Okay. The lesser of three evils. Okay. Now, here it talks about refrigeration coils, which really means generally evaporator coils, could mean chilled water coils. Refrigeration coils shall not be installed in conjunction with forced air furnace where circulation of cool air is provided by the furnace blower unless the blower has the capacity to overcome the external static pressure resistance imposed by the duct system in the refrigeration coil at the airflow rate for heating or cooling, whichever is greater. It's always going to be greater for cooling. Okay, we have this general principle. Heating, you want a very slow, soft air speed. Generally, systems run their fans at low speed for heating, so you get this warm, gentle heat on you, and you don't have draftiness. You don't have a fan blowing air on you, which can make you feel cold, right? So heating is gentle, and then with cooling, we want fans, we want air, we want more air circulation, right? So there's been a history. The history of air conditioning is heating first, and then a lot of people would just jam in a cooling coil somewhere, which I've seen even in modern jobs. Old heating systems just jam in a chilled water coil, or 500 of them, which I've experienced in a school. But then does the fan have enough air to provide that high speed? Does it now have enough air strength to overcome the pressure drop of that evaporator coil or chilled water coil in the ductwork? And maybe you have to, change the ductwork or upsize the fan motor or change the pulley ratio or whatever to get the air you need for cooling. Now, here's a question for you. Riddle me this, Batman. In a system like this, and here you've got the condensing unit outside. Here's your evaporator, your thermostatic expansion valve, the condenser, the compressor, okay? On this split system, an upflow system. At what point in the life of this unit, at what mode of operation is the evaporator under the highest pressure? See if you can think about that and give an answer for a minute. Is it when we're running the cooling? No, it's not when we're running the cooling, because when we run the cooling, the pressure on the low side drops down. You'll say, well, I know the answer, Mr. Needham. Of course, it's during the off cycle. It's when the unit's not running, then the low side pressure is higher. That's the right answer. No, it's not. It's actually when we're running in heating mode. When we're running in heating mode in the winter and you're not thinking about it, that's when you have 120, 130 degree air blowing right onto your evaporator, and the pressure temperature relationship stays, it's still valid, and that's when you have the highest pressure. That's why the next code was written that says furnaces shall not be located upstream from refrigeration coils unless the refrigeration coil is designed or equipped so as not to develop excessive temperature or pressure, which is the case here. For a lot of these upflow or split systems that we have, yes, this coil might be get 120 degrees, but it has all of this refrigerant piping and all of this room here to help dissipate that pressure and drop it a little bit, because it's going to be colder outside when you're running the heating, right? the refrigerant's going to be flowing here, going to this lower pressure now outside, and actually your evaporator will be under a higher pressure than your condenser. Did you think of that? When it's cold outside, when your evaporator will be, when you're running heating, at a higher pressure, and you'll end up with this unit out here tends to dissipate it. Okay, so a lot of times it's acceptable, but you'll still end up with a pretty high pressure. So here's a service tip for you. If you have a leak that you just seem like you can't find, and the system has refrigerant in it, you know, maybe what you should do is flip it and run it in heating for like 3 minutes or 4 minutes, and then shut it off, and then while the evaporator is still really warm from your heater, do a leak check here, because the pressure will be higher. The higher the pressure, the easier to find the leak. You learned it here. Okay, now, all right. Also, you have to have a condensate drain here to take the condensate off the evaporator so it won't drip down and get rid of the products, the condensate, because whenever you're running cooling and air hits this cold coil, water falls out of the air onto the evaporator. You have to have a condensate drain pan and usually a pipe, a PVC pipe, to take that outside. Okay. Okay. Now, the other point I wanted to make was, on a package unit, where everything's in a package on your roof, you generally have the opposite. You generally have the air going over the evaporator first and then across your heat exchanger, so that you don't have this scenario, because you don't have all this extra room to dissipate the pressure. So the design is usually a little different for a package unit than some split systems, where in a split system, quite often the heat exchanger is upstream where the air hits it, and then that hot air hits the evaporator coil. We flip the script a lot of times for a package unit where the air goes across the evaporator and then the heat exchanger, and then if it heats up, it's just going out the ductwork and you're not warming your evaporator. Hidden knowledge. All right. Now, here it talks about electric duct heaters. And actually, believe it or not, I think I found an error, not in the commentary portion of the code, but in the law portion of the code, which is exciting for me. Here it says, electric duct heaters installed with an air duct shall be listed for such use and designed for the maximum air temperature. The duct heater and fan shall be interlocked, such as the electric duct heater operates when the fan is operating. It should be written the opposite. It should be saying the fan should operate. It should be that you can run the fan and without the duct heater. But here it's saying, like, whenever you go to run the fan just for ventilation, you need to have the duct heater on, which is wrong. It should be that whenever the electric heater is on, you've got to have the fan running, but not the other way around. Otherwise, sometimes we just need ventilation without heat. Okay? All right. On clearances, the lowest portion of the floor furnace, now if you have a floor furnace, shall have not less than 6-inch clearance from the general ground level. Okay? A reduced clearance to not less than 2 inches is permitted, provided the lower 6 inches portion of the floor furnace is sealed. So what we're talking about is floor furnaces. Is these are like old furnaces in houses that are only about sitting on the floor, and maybe there'll be a little piece about this high in the back, and then it's like usually a raised foundation, and most of the furnace that operates the gas valve and everything is actually below the floor level in your, and sticks under your house in that raised foundation. And so we don't want a flood to come and to get in your heater when you really need it. So it's got to be off the ground 6 inches generally, unless it's a special design with a sealed chamber, then they only make it 2 inches off the ground. Okay? All right. And now let's talk about wall furnaces for a minute. Wall furnaces mounted to the wall that stand up about this high, and then they have the vent, that BW oblong vent that goes through the wall and up. Sometimes people in there wanting to install it will do other kind of strange things and screw on the panels to the drywall that you need to get off for service to troubleshoot it or fix it or whatever, maintain it. And that's not acceptable. And what's the code saying is that if a panel is designed to be removed in order to work on it, you can't take that outer cover panel and use it to screw into the wall. Okay. All right. And then all dryers shall be exhausted to the outside atmosphere. And actually, I had a student one time who told me he thought of a great idea to save energy. In the wintertime, he just undid his exhaust pipe, the 4-inch corrugated pipe. He just took that off and let the warm air blow into his house. And he thought it was a great energy savings thing. And I said, well, isn't that portion of your house by the dryer really dirty? And Lynn goes, I don't care. Yeah. I go, that's kind of a fire hazard too. So it's not good to have that products of combustion and water vapor and all that lint and everything blowing into your house. So that was an odd moment for me. Now, also, when you're putting this ductwork together with the lint that can and everything be in the duct going outside, you can't have screws going inside the duct to attach it to something else, because believe it or not, even a small screw like this that gets into the duct can act as an anchor, and then you can like build a giant tumor of lint around it and cause a big obstruction, okay? Because it's kind of like wet, the lint, it's moist, and it'll stick to the metal and then dry, and then more lint will stick to it and dry, and you can actually plug up your entire vent with lint over the course of a year or two just by one tiny little screw being drilled in 2 or 3 inches, or we'll say into a exhaust duct for a dryer. Okay. Fireplaces need to have a screen in front of them or called a spark resistant screen, so that you can't get little embers that pop out. And by the way, according to the code, we consider a fireplace that makes a nice, beautiful, warm orange fire. We consider that by the code, the proper name is a decorative appliance. It's a decorative. It's not really for heating, right? 90% of the energy that you use, the wood or whatever you're burning for your romantic evening, is going up your chimney, and only 10% is radiating out into the room. So actually it's called a decorative appliance. The first person to invent a very efficient stove, and fireplaces are sort of combined early on 300, 400 years ago as like you would heat your home and cook your food all over this, right, was the Franklin stove, which used like half the fuel but gave you 4 times the heat, because it had these chambers that went around, invented by the great godfather of electricity on your C note, Ben Franklin, my homie. Okay. Now, there is something called an industrial heater. And I've thought a lot about this. This is a little odd. Industrial heaters can be used, and you don't have to vent them outside. They again, a perfect flame, perfect combustion produces 0 parts per million carbon monoxide. So not in a residential setting, not in a setting where anyone can sit down and go to sleep, but in an area where people are up and working. They won't let you recirculate that air, but they'll allow you to bring in 100% fresh air. It can't be recirculated where anything can build up. You've got to be taking 100. They have these type of industrial heaters where you can take air from the outside, heat it up, and blow it in, and the products of combustion go in there too, into the space. But it's more like a temporary heating thing. And again, no one has the possibility or shouldn't be sleeping there, and they don't ever recirculate any of the air, so nothing really builds up. It's just kind of in and through and out. Okay, so we have that industrial type of heating. Okay, must by code use 100% fresh air. Okay, again, unit heaters are mounted up against the ceiling. There may be a small clearance of about 6 inches, or depending on design, maybe only 2 inches if the manufacturer states that. And again, that's non-residential, more for like a automotive garage or a gymnasium or something like that. And then again, people don't like them because cosmetically you have something just hanging from the ceiling, which though, especially if you have like 10-foot or higher ceilings, to me it's kind of like interesting, because then you're actually saving space, and you're not losing any usable space, but people cosmetically don't like them to see units. To me, it's the most beautiful thing in the world. Okay, now, all right, so that's the unit heater. And then a unit heater shall not be attached to a warm air duct system unless marked for such installation, right? Most of these unit heaters have prop fans, just like a box fan type that blows the air through. And I have kind of a general rule that says we use prop fans when there is no change in direction of airflow and no duct work. Condenser fans, just through the condenser and out of any kind, a prop fan. Think of a window unit with one motor and 2 fan blades on the end. The one for the condenser is a prop fan right through the condenser and out. The one serving inside your house has to make an air change like this, and it's a centrifugal fan, right? Like a squirrel cage fan. So you can't be attaching ductwork to a unit like a unit heater that's designed with a prop fan and then messing up the airflow and everything by putting ductwork on, and that prop fan is not designed for that. Okay. All right. Here, a vertical distance, vertical clearances, a vertical distance of not less than 48 inches shall be provided between the top of a food service hot plate and griddles. And then we also have 30 inches from a cooking top. 30 inches means from your stove to anything, you should have at least 30 inches. And actually, in my kitchen at home, I think the microwave is part of the microwave. And for the back burners, I always tell my wife, don't use the back burners if you don't have to, because it's low. It's lower. I don't know what she was doing, but at one point there was kind of a flash up, and she melted the microwave, and we had to replace it. And that's another story. But anyways, you have to have proper clearance over your cooking things by code, so that you won't have fires and things of this nature. Okay. Then to finish up, here it talks about factory-built commercial incinerators and crematories shall comply with UL 2790 and installed in accordance with manufacturer's installations. Now, we don't really, especially here on the West Coast environmentally and probably throughout the country, we don't have incinerators. There used to be incinerators like in big buildings back east, where they would burn part of their trash as part of the building service, which is very polluting. And a crematorium is like where we burn people. Ashes, you know what I mean? Like you put them in an urn and everything. And so I've never worked on either one of those, but a couple of things coming up now, weird stuff I have worked on. It talks about pool heaters. They can be very hot, and around pools you always have kids running around. That has to be fenced off where they can't get to it and get burned. Also, refrigerators, talking about old school refrigerators, like with that grill on the back that looks something like this, but just no fan, just a big grill, static. It's called a static condenser. It says not less than 2 inches between the back of the refrigerator and the wall, and 12 inches above the top. Now, generally, that's super old school thinking, and that we want to have airflow all around the refrigerator to dissipate the condenser heat from these old school type refrigerators. And sometimes you still have little under the counter little refrigerators that have that static condenser with no condenser fan. And so you do need to have air clearance so that you can have air movement around it to dissipate the heat and lower your head pressure. Generally speaking, though, most modern refrigerator freezer combos that you have in your house, what they do is down low, they have like a grill, and they take the air in one side and blow it through the condenser and have the air come out the bottom side, and then people like make them seamless right underneath the cabinets and everything and build them in so they're nice and tidy and more appealing to some people. Okay? It makes it a mention here, and this kind of tripped me up when I first read it, dealing with gas-fired, wait for it, gas-fired toilets. What is that? This is where you burn your excrement, your crap, in a cabin in order so it doesn't build up. Like off in the remote, there's something where you actually use it, and you burn it, okay? I just thought I'd mention that, just so if you want to know what a gas-fired toilet is. And then I have one time worked on a kiln, which is where you fire pottery or clay. That's part of the code there. We talked about industrial. It says the provisions of this section apply to kilns used for ceramics that have a maximum interior volume of 20 cubic feet and are used for hobby or non-commercial uses, right? So if you had a kiln and you're firing pottery to make, pump out 1,000 vases a day or something, then that would not be under the code, okay? Because that would be an industrial type process, okay? And you have to have a hood above every kiln, okay? Then evaporative coolers, again, evaporative coolers, the slang name is swamp coolers. They have to be 3 inches up off the ground. Just like, even that's a rule also for condensing units. You see the little green here? That's grass. I took the time to draw you a little grass. And the white is this, so this, you might have a cement pad or a pad from the manufacturer or parts house, 3 inches to keep this off the ground, the condensing unit, 3 inches off the ground, evaporative cooler, 3 inches off the ground, so that if there's a flood, you can compensate for that. If there's a heavy rain, we'll say, it won't get water inside your unit, okay? And again, anything that's supported from above, like hanging like on all thread or threaded rod, if it's being supported from above, you have to have 6 inches of clearance off the ground. That means nothing would be underneath it, though. Okay, and then finally we conclude the unit where it talks a little bit about high efficiency particulate air filters shall be installed according to the manufacturer's instructions. What is the abbreviation for that? A HEPA filter. Okay, those are some interesting points for installation of specific appliances. Thank you.